the idea that there is a set of pages that are kind of like in that net, and then from that set of pages, some are selected and some are not. That felt like the most kind of like actionable idea to me of like, okay, so there's a bunch of stuff about just like fundamentally how it works, but that concept actually starts to point at what you might do about it. It starts to point at something actionable and measurable, which is, okay, well, if you can establish all the pages that were in the potential consideration set and you can establish which pages made it into the final response, now you've got a more actionable kind of feedback loop and evaluation mechanism to actually start like doing things. Because I think part of what I have problem with a lot of the ideas in the AI search space is that they're just fundamentally not measurable or useful, right? And so like, yes, there's a lot of things are changing, right? Like AI mode, radically different, ChatGPT, radically different. Like it doesn't look like search, but what you actually do as a brand, as a company, as a business is like kind of the same, right? You got to publish content, you got to like, optimize for intents, etc. But I think what was interesting of your presentation, like I think it really started to like expose the idea of like, okay, well, if things are different, how might we react? And that's the bit that I think is kind of most exciting to me personally. But I'm kind of skipping over a little bit of like, I think I'm also fairly familiar with some of the backstory. I think a lot of the backstory was also very well explained in the presentation. So,
Cool. Fantastic. All right. For those who are wondering what we're talking about, is a slideshow that I put together for a presentation in Amsterdam. It's something that I've been banging on for a while and preaching and trying to reinforce certain concepts, introduce certain terminology, provide a little bit of background. A lot of people reacted quite positively to the slides. Probably took me by surprise because I've had a lot of different presentations in the past, but this one is like people like put some voice over this. And I think that's the part we didn't quite record earlier, is where Tom brought up the fact there's like, yes, there's the material there, but people want to hear what goes on top. Can we have a narrative that goes on top of these slides? So
we need more context
there in Amsterdam. Yeah, a little bit of hydrate that with some backstory and so on.
Right.
So I'm going to go with Tom's feedback here on getting more into the practical side. So the first part of the presentation goes through a bit of history from me predicting us chatting to Google today back in 2013 to evolutionary timeline, the way I projected it, and a bit of history of how things have evolved over time. I'm going to do a nice little skip over that and let you explore those slides on your own. And I think one thing that's probably interesting to present before we dive into the rest is, I think quite important to understand is that, okay, so Google came up, or a department within Google came up with transformers. Transformers were picked up by OpenAI, and they're like, oh, cool, we'll take this. And then they made GPT, and then they made some arbitrary decisions on how they will do the GPT. Basically, pick 12 layers and 768 DIMMs because it would train for a month and fit on a dev box. No other reason. I mean, he wasn't gonna wait 3 months for the training. That was at the end of his patience. So Alec made these choices, and then Google's like, okay, well, they know what they're doing, so let's do the same thing so we can compare the results. So that's how BERT ended up with the same dimensionality and same number of layers for the BERT base, which I found hilarious. And this was like, I only found out thanks to his tweet that's up. So they basically made history. So I think, but the main point here is that these are not large language models. These are small language models. I mean, they've got 100 million parameters, and they weren't as capable as you would imagine a large language model to be today, or language model to be today. So what we're seeing here is size of the model stepping up. So more parameters, more parameters, more parameters. And this is the number of errors it makes. So as you make model bigger and bigger, you reduce the amount of errors it makes until you make it too big. And the model just memorizes all the data because it has the memorization capacity. And so it learns everything for the exam, but can't generalize when it gets in the real world situation. So these models are useless in a commercial setting because they can only answer what they've been trained on. So the trick of the trade in the past was create models slightly smaller, less capable, so they don't overfit.
Right.
Basically, they can't memorize everything. And that was the conventional wisdom at the time. This guy comes along, is like, yeah, I don't care. Let's keep training. Let's make it bigger. I don't care. And he basically not discovered, but like reinforced the notion of double descent. So essentially, this descent that we were seeing earlier that ends up in the rise, and people stop training or increasing the model parameters at this stage because, of course, it's going up. It's just
Right.
keep going up. People just didn't think, like, why would it start getting better after it gets worse? It's really unusual behavior. But it did. And two companies, among many others, paid attention to what's going on because the writing was on the wall. It's like, we can just make it bigger. So it's just a matter of scale. We don't have to do too much more complicated stuff. So they made, they went from 100 million parameters to 1.5 billion. And it's like, okay, starting to form coherent sentences, putting things together, and then, okay, let's make it even bigger and bigger and bigger. And so welcome to today. So the downside of making such large models is that you have no idea what it does and why it does. Like, we know there's like an emergent property of it. It can talk to us and it seems intelligent, but nobody knows why it does things that it does. And we are SEOs in position that we have to work this out. The thing is, relax. Nobody knows why they do what they do. Not even Anthropic. Grok team doesn't know why Grok does the things that they do. The Gemini team doesn't know either. It's essentially too complex, and some of these things are largely emergent properties, reasoning. They can kind of like form ideas. And so I wanted to introduce the concept. Sounds sciencey, but all we need to know about this mechanistic interpretability is something you can do with open weight models and open source models, looking at activations, looking at the circuitry, and basically seeing what activates when you do what. We can't do quite that with closed source models like Gemini and GPT, but there are thought leaders, formerly OpenAI, Mira Murati, who is now running Thinking Machines. That's their mission, to understand why AI does the things that they do. And this genius here, that everyone should pay attention. I presented him as the best SEO, AI SEO in the world, and he doesn't even know. Effectively, he's the hacker that understands the AI whisperer, let's call him, right? So he worked at Anthropic, well, co-founders of Anthropic, but coming from both OpenAI and Google. He knows what he's doing. So basically reverse engineering artificial neural networks into, he's a translator, essentially. What does it do, what it does? I'm going to skip over the fact that I'm just going to say I trained a large language model, or a smaller large language model, just to understand how it all works. So I basically done it from scratch. There was no fine tuning. I didn't take BERT and go from that. I just basically took noise and created something out of noise using masked language modeling. So saying that just to establish the fact that I at least know what I'm talking about in terms of, okay,
sure.
Dan pokes his stick at a certain point and he knows where to poke the stick at. He doesn't really know what it means, but I've got some clues that perhaps not everyone had the luxury of the time and focus to be able to dedicate to. So that's why I'm sharing this. So a bit of a trust me, I know what I'm doing moment here.
You've got a lot of credibility and you've built some cool stuff.
Yeah, I had to like pump it up myself, just like, yeah, like believe what I say next is probably true. Because I don't like when the SEO industry says, "Oh, we're all AI experts now. We've solved this problem." We haven't.
Yeah. What I like also is like the humility that you're pointing out, which is like nobody knows. There's a lot of things here which are true kind of frontier science, right? Nobody knows exactly why they behave the way they do. There's lots of unsolved problems. I think that's exciting, but I think everyone needs a dose of humility here, right? Like we're all figuring it out as we go.
Absolutely. And there's a lot of great work being done in the industry. People contributing, yourself, Mike, me, Andrea Volpini. Everyone's looking at it, and we're all adding to different pieces to the puzzle, trying to put it all together. And I guess we can look at this as a bit of contribution that I'm making. So let's scale it back to like a normal user experience. So you type in a prompt, prompt gets fanned out into multiple fan out queries. Google is Googling itself. Instead of us having 20 tabs open, Google is doing it in the background, presenting all that grounding context in form of search results to the model, and model makes the response and then bolts on citations on top of that. So the big complex query gets broken up into small constituent parts, each one reflecting an aspect of facet of that complex query. And then for each search query, we get different set of results coming from Google. And then we get a massive amount of grounding results. Not all of these grounding results end up being visible to the model. There's a layer of filtering in between. So there's a classifier or a system that filters this through. So when it arrives to the model, we're only seeing a limited amount of grounding results presented to the model. So you can frame it almost as a re-ranking system that cuts off a certain most valuable context and gives that to the model. And then the model selects which ones it's going to integrate in the final answer, with slight nuances between how Google thinks about it and how OpenAI thinks about it. Google basically takes the whole lot and integrates it in, whereas OpenAI does a bit more selective stuff. And I think that's interesting, perhaps, to have this discussion. So, okay, so Google Googles itself, something filters the results, robot makes the selection, and then that is being supplied to the model for review. So two types of text input come to the model. One is the search results snippets, not the full pages, snippets from bits and pieces from pages, and the original user prompt. So that forms the text input to the model. Now, this is interesting because a lot of people like, does schema end up in the grounding situation? No, not in its original format, because it's all blended in as text or markdown, and that's what model sees. Did schema contribute towards that ending up in plain text? Probably. It's helpful, like if there was a price or a product review that wasn't necessarily in the user-facing stuff, but it was in the background. But it's a design choice, software design choice. So you can't generalize and say, yep, go ahead.
Well, I was going to say, I think there's in my mind, and I'm curious if you agree or disagree with my perspective here, I think this is a crucial step where a lot of things are going to change. So today, and I think it's like a month or two ago, it came out that Google was using what they call fast search under the hood, right? So when they do their query fan outs, they're not using google.com search. They're using like an internal, faster, lighter weight version of search that enables them to get the results back quicker and faster to be able to do this in real time, right? My opinion is that, like you said, today, it's pulling snippets of those pages back as markdown. I don't see any reason why Google wouldn't annotate those snippets with things it knows about the web pages and things it knows about the sites, right? So there's no reason why, instead of using fast search, it should use extended search. So it gives, like in a JSON format, the kind of information that you don't get on the front end of Google, things like maybe a page rank, an EAT score, a content effort score, all these things that we know make up the algorithm today. So the model can make a better informed decision to choose which of these snippets to trust, which of these snippets to use, which of these sites are more authoritative than another. And I don't think it's doing that today. I think today, it's pretty naive, right? I think, like you described, it basically takes a bunch of markdown snippets, shoves them in the context window. But I don't see any reason why this couldn't get a lot more advanced as Google builds out more robust things here. And I think as that happens, I think we'll see a lot more sophistication and nuance come into which of these citations are making it into the final answer.
Yeah, I think you're exactly right. This will continue to evolve. Google wanted to start with the minimum viable product and build on top because they were invigorated by OpenAI's advancements, and they're like, "Oh, we got to do something quick." So they were activated. I'm very happy about that whole thing because it's doing a lot of utility for the end user. One thing that's actually happened recently that's important to add as context is, yes, Google is using its cached web to supply results very quickly. All the grounding sources are coming not from the live pages; they're coming from Google's cache of those pages. That's why it's lightning fast. And that's a huge advantage Google has over OpenAI. OpenAI has to go and fetch the pages. They don't maintain an index. And Google can just very cheaply tap everything. That's why they're grounding everything. You ask Google, with grounding enabled, you ask Google, is water wet? Is the sky blue? They'll be grounding that. Doesn't matter. So they're really solid about determined to prevent hallucinations. So one thing that shifted recently, and I proved this conclusively, is that raw HTML actually ends up in Google's grounding situations. So whereas OpenAI might see a bit of a markup-ish, like a markdown stuff, Google actually has access to HTML with, B tags and divs and things like that. So there's a chance that schema might end up in there. But from what I've seen, the raw schema can get clipped because they do, and this is interesting work actually. How do you predict how Google will take bits and pieces of different content to form a snippet that represents you to the model?
Right.
Because it does not necessarily want to show the entire page. So,
well,
anyway,
that's where you have a tool that you just released for the progressive summarization, right? Which I think plays a key role there. I think both Google and ChatGPT will almost certainly have a pipeline to do that in a systematic and repeatable way, right? Rather than letting some kind of wild west of like, oh, maybe we cut off your schema halfway through, or maybe we cut off a paragraph halfway through, like having a more robust pipeline of like, this is how you take a document on the web and convert it into, short snippet, long snippet, full text, full text with annotated data, etc.
Exactly. So I love that you mentioned this because so when I release a tool, it's usually because I had a problem internally that I've solved.
Right.
And I'm like, okay, let's help others and push that out. What I don't do is like, my tools are normally part of an automation pipeline. Obviously, I can't give that away for free, but I give you that one segment that helped, and here you go. Here's some ideas. Feel free to steal it, take it, reuse it, or just use it as a one-off tool. So semantic compression tool helped solve the problem of how do we make each grounding segment stand on its own legs when isolated without the context of the rest of the page to prevent misinterpretation of products, services, brands, and the intents. Particularly important for OpenAI and the way that they do things. Just days ago, I discovered that they use a sliding window. So the model is essentially not seeing the whole page. Google has that luxury, OpenAI doesn't. So they're like scanning. So you have this one window and they can sort of slide which part of or jump to a line number and to grab that piece of content. I thought that was a little bit weird, but it is what it is. It's how it works at the moment. So this is all presented as text output, and then they bolt on citations on top to sort of ground the generative output with world knowledge. So that generated text ends up being that link. So that's what we refer to as the citation. Within the citation, you could have a brand mention as well. Two distinct concepts: brand mention and citation. Citation, when you actually use as one of, like when your actual URL was used as a grounding source. And the brand mention is you don't necessarily have to be a citation, but you could be a mention within that citation. So just disambiguate that. And typically Google uses a little chunk. Like if you actually click on that, you'll see it highlighted. And that tells you, okay, well, they're using text segments to identify how to form these snippets internally.
And just to pause here for a second, if you go back to your diagram that you had, this one. Again, correct me if I'm barking up the wrong tree here, but my understanding is that these citations is like a bad crutch UX, right? It's like they're like these little link icons. Nobody clicks them. They're out of the way. There's lots of kinds of AI responses from Google in particular where it says something that you'd love to click, like a product name, right, or something, but it's not clickable, and instead it has this little citation link. Part of the reason that I think they do that is purely for speed, right? So you mentioned this idea that ChatGPT is slower, has to go crawl the web, has to go fetch those pages and so on. But at the same time, I find ChatGPT's default response often has more thinking in it. It has more cycles of thinking, right? So it assembles the sources, figures out what the response should be, and then kind of intermingles the sources into the response in a slightly more natural manner. Whereas Google, especially AI mode, is pretty belligerent about only including links as citations, right? And my hunch is that they're doing that today purely for like speed reasons. I'm hopeful, and again, I'm kind of an advocate of the open web. I'm hopeful that like links will kind of come back into these responses as they figure out how to do that in a performant way. Would you think that's fair, or like is there some other reason why you think the citations kind of UX is going to stick around?
I have I've harvested probably millions of citations now. I spent a lot of money on that. Collecting citations is expensive business because grounding Google's model in SERPs costs 10 times or 100 times the normal generative answer.
Right.
So I don't know why they price it so high. And I think that's why OpenAI and Google deal kind of broke, and OpenAI is now scraping, I guess, Google.
Yes. Yeah.
We've seen evidence of that in people's search console. If there was an API pipeline, this wouldn't end up in Search Console. This was scraped stuff. To me, there's no other way to explain it. I'm not going to speculate on that, but it's clear that there's no commercial value in paying such huge amounts. Long story short, I've seen a lot of citation mining data. I have a gigantic data set on that, and I've seen evidence of Google actually linking to stuff. And basically having that little tiny little link. I don't know. Do we have a screen? Yeah, that little thing. But there's also moments where there's an actual link within the text. And here's a little useful thing for everyone to do. Let's say you're the citation, your own domain. All you have to do is put links, internal links to your own assets. And that influences the actual link in the generated response. Google will basically never highlight your product, service, brand name and link it to some page. You have to do it on your end. So if you have internal link optimization done properly and all your key entities are linked up, they'll end up, not guaranteed, but they're more likely to end up in these generative answers as an actual hyperlink.
You're talking about internal anchor links or just internal links generally?
Actually, don't know. From what I've seen, there were like a bit of both, I suppose.
Yeah.
But I'm particularly focusing on just a link from page A to page B, basically. So let's say your blog page is a citation, and on that blog post, you're linking to a product that you're offering. If your blog post is the citation and the product is part of the citation content, that link that links to your product page will then be included in that rendered model response. So you'll actually get a nice clickable element there. And that's huge.
Right. Can we jump to a live search for a second?
Yeah, sure.
Yeah, because I think this is a really interesting point to me. So I don't know if you'll get the same results as I do, but pull up a search for dinner ideas.
I'll do AI mode, yeah?
Yeah.
Anything in specific or just dinner ideas?
Just put dinner ideas. It's so here's what's interesting to me, right? So it's like, in my mind, when it says lemony tuna pasta and it says sheet pan chicken fajitas, like they got to be links somewhere. Like if Google decides to link to themselves, that's one thing, and that would be fine, whatever. But like this citation like UX, I feel like it breaks down in so many situations where I think if Google gave themselves a little more time to do some like reasoning somewhere in this thinking, they would end up with a better like link-based UX here. And again, I'm biased because I care about the open web, but like I feel like there's lots of situations where this citation kind of UX is just not good for the user, right?
Let's jump practical stuff. So dinner ideas. I'll go into this, and I'll go to expert citation mining. I'll just do this. Create run. Okay, I'll put some entities in there. Yeah, single entity. That's fine. Generate some prompts. I'll generate 10 prompts for that one. So if I entered like 10 entities, and 10 prompts, I would end up with 100 prompts because 10 per entity. And then I go mine citations. So I'll do maybe 10 rounds per prompt, OpenAI and Google, and start mining. So this will do 200 operations. So while we're talking, it'll give us some results to look at in the end. So basically, the point I want to highlight is that once Google delivers these citations and OpenAI, we'll be able to see a key difference. And this is the fact that I think I already mentioned it, but I don't think it quite I made it quite obvious to everyone listening. Basically, when Google does the grounding, they will ground a single fact with multiple grounding sources. OpenAI will do a single fact or a single chunk, let's call it, with one URL. It's a software design choice. And then that's the frustration that you're seeing there. So for example, this is a grounded fact. Yeah, that's the chunk that they're grounding. And this segment is grounded with these two URLs as citations. If this was OpenAI, this would be a single URL grounding a single chunk like that. So OpenAI goes a bit more granular and they go one-on-one, whereas Google does multiple grounding sources, and that's what makes it impossible. How can you, so they have this one little thing, and you can't really provide, I mean, you could provide 1, 2, 3, like footnote style citations. Also not ideal, is it? So they do this thing on the side. So it's a bit of a clunky user experience there.
Well, and I think that's what I'm trying to get at is like philosophically, in my mind, there's kind of this distinction between how the model is working under the hood, which is technical and has nuance and so on and so forth. But then you've got this kind of like separate consideration of like, what should a result look like? What do users want, right? And I think we know that there are lots of kinds of queries where users want links, right? And this is a great example, I think, where it's like, this would just be categorically better if each of these recipes was linked somewhere. Even if it went to a Google search result, it would be better than what it is here. And how does the model, is that just a better prompt, right? Is that just like better prompting on Google's side to like tell AI mode, like when the user wants links, add links in? Or is there some technical limitation? Because in my mind, I feel like the citation UX almost feels like a technical limitation more than a prompt design problem. But maybe it's a bit of both.
Yeah, I think it's just their user interface front end team, that the choices that they made and the best they could do in the limited span. I'm sure they're working on a better solution right now.
And that's what I'm hoping too. Is like I feel somewhat optimistic. Like, and again, as an advocate for the open web and publishers on the open web, like I think there's a lot of these kinds of examples that are already bad and don't have any links in them. But I'm kind of optimistic that I think Google's going to add a lot more links back into this as they realize a lot of what made regular search good is the links, right? Again, not to like, it's still going to spit out an AI generated answer and like it's still going to be different than what it was today. But I'm optimistic that they're going to put more links back into it in smart ways.
Fingers crossed, because that's
fingers crossed.
Yeah, we're perfectly aligned on that. Evidence that they do obviously put links in is that they are there, so they can and they will. So obviously, so this is the process and logic. So you can imagine, let's say I put 100 entities for a client, and I generated 10 prompts for each. So I've got 1,000 different prompts, synthetic prompts, obviously. And then I do a citation mining. So I do 10 rounds for each one. So I've suddenly collected 10,000 each. So I've got 10,000 OpenAI, 10,000 Google, and that will give me like maybe 100,000 different citations. So there's a massive amount of data just from a single run to collect. So I've been looking at this data set for quite a while, and I did find instances where these links integrate like mid-sentence. And you just got to have the internal links. Old school SEO, you just got to have the internal links present.
But like bring that to life for me. Like on this page we're looking at here. So for example, like those ones that are linked at the bottom, like do we have any inclination as to why they were chosen? Why they were chosen?
These are the 3 of the grounding sources overall. So basically,
but not necessarily tied to the individual.
No, this is like a summary and end statement. We don't have a good example of them using like an mid-sentence link because it's in the content of that page. I'm sure this website probably has like, yeah, there you go, these internal links. So if you have any chance of having these links show up, you have to have them in the first place. So how do you optimize for that? Well, the link has to have a good purpose, good place already in there. One way, I guess, to keep people with, like, to give people something practical to do, if I take this URL, LinkBERT is a model that I trained that I can use. One of the tools also used in the presentation. So if I take, let's say, go back to that URL and take this piece of text and see where links would naturally occur in that bit of text, you know, probabilistic wise. Those are probably the most likely spots. Nowhere in this piece. Well, just my luck. Let's try to lower the threshold, see if it'll be a bit more generous. Oh, there you go. That's the first most likely link at the 50-50 threshold, which is typical of deep learning models. So from clever ways with chicken breast.
Wait, so break this down for me. I think I'm following, but I'm not even sure I'm following. So I'm sure folks watching this might be having a hard time. What exactly are you suggesting or implying with this methodology?
Okay, so effectively, this deep learning model has learned where links appear naturally on the web, and where there's a good intuition, good feeling, this link is useful to have, right? So we've now lowered our threshold down to 50%, and the first link that's appeared, so obviously the model hasn't seen the links or HTML, so it's feeling out where in here is the best place for a link, and it predicted that. So if we go back to the page, that's the link actually exists. So we could go further and go like, well, lower it further to see what else it'll paint as potential links. So as we lower the threshold, it probably loosen its criteria. Okay, clever ways with chicken breasts. All right, what did they do? To pasta dishes. Okay, we basically predicted human behavior, what this author was going to do. We predicted this link and that link.
And so again, if I understand correctly, what you're saying then is, if you have a piece of content and you ran it through this tool, it would suggest smart places for you to add internal links. Is that the kind of workflow that you're implying?
Not necessarily smart. It'll predict the most probable places where a link would appear naturally as per our training data. We trained our link model on TechCrunch, Gizmag, Wire.com, all the best of the best, non-spammy. We didn't train on link networks, obviously. So how normal web authors would choose to place a link. And this is important because when you're considering how Google will make choices, they will reflect the same type of training. Oh, the training data, that was a link, I will make a link too. Because models are trained on the web corpus in the same way that our deep learning model was trained on the web corpus. So they've learned when and what to create as a link. Now, with the important distinction, Google will not go and create a link where it doesn't exist. It'll only choose when to keep a link that fits a pattern of useful links being on the page. If it doesn't fit this probabilistic pattern, the link, that's my running theory at the moment, and it fits. I test again and again and again, and where links appear. So for example, I will find an instance where I have links like that appearing mid-sentence, and I'll run it through the tool and it'll be highlighted in green. As you can see, this one is a bit stronger and this is a bit weaker, right? So the probabilities of them being links is varied. right?
Yep,
Based on the truth. So we took a little side quest, but I think it was quite valuable and
Yeah,
interesting.
yeah, I think this is super valuable. Yeah, sorry for taking us taking us off track.
Like I think there's value for people already. Like, look, what to cook, that's a link. Dinner ingredients, that's a link. So if you're considering how to optimize your content for internal links, LinkBERT is your go-to model to, and by the way, you don't have to use this tool. LinkBERT is published on Hugging Face. You can build your own tools with it. The brain is there. You just need to surround it with some scripts in Python and so on. Okay, so that gives us. Let's see if the citation mining is finished. So let's look at the stats. So these are the top domains OpenAI chose to include, and these are the domains that Google chose to use. So we've got the top citation URLs for OpenAI and Google. So Google, out of that little run we did, this page appeared 93 times. What is so special about this? So we do two things in terms of optimization potential. Create lookalike content that just hits the spot with Google the way this does. Format, style, whatever they do, try to reverse engineer that. Get in with content of your own that looks like that in hope to become a citation. Number two, get into these types of domains with the lookalike content ahead of your domain being in there, because you already know that they're being selected. So just give them something that looks like this to them with your brand mention in hope to get visibility ahead of time without waiting for you to become one of those grounding sources. To get the brand mention, hopefully the link. Now here's the nuance. So for the entity dinner ideas, for the prompt, whatever that is, the Google's grounding URL is that, and we get confidence scores as well. So each confidence score tells us how likely is that URL to be of utility for that grounding chunk. And sometimes it's a very high score, sometimes it's a very low score. Whereas OpenAI doesn't give us the probability scores, but they give us the something even better, I think. They give us what they've browsed and chose not to include. And they give us what they chose to include. And that each one of these, of course, we've got the entity mapping, we've got the prompt mapping, we've got the grounding source, and we've got the exact chunk of text that grounding supports. So if we look at the raw responses, you can see, I guess, a bit more clearly what that looks like. So this is the Google's response, and this is their grounding situation. So this is the chunk that was grounded. And here you can see that they for a, let's sort it by that. You can see multiple grounding sources supporting the same chunk and vice versa. So Google will do that from time to time. Whereas OpenAI, they do more of a one-on-one situation. And so for each one, you only get one grounding support. Oh, that's we have quite a lot of data in there. So as you can see, like it's probably not feasible to do human analysis and human review. That's why we use tooling to help with this sort of work. But of course, if you want, like, you can just get to raw data of everything, and you can see what is it the API response actually gives you.
And these are just coming straight out of the API responses, or you're not scraping anything here.
We're not scraping. We're trying to understand the choices that models make when presented with certain grounding sources, and what do they. So this is all gearing towards selection rate optimization and understanding what the performance will look like. So that's probably the most exciting work in the whole thing. So
yeah,
that was
so if you flip back 2 slides in this presentation, kind of maybe try and get us back on track, maybe. And I think maybe you have a different visual as well that might be even better. But like, I think this is a really important point, because this was the thing that really jumped out to me from this whole presentation when I was reading it through, was there's a lot of noise and hype and buzzwords and all kinds of LinkedIn hustle bros talking about all kinds of things about GEO and AI search and how it works and what to do about it. There's some things that I think are very bad advice, and some things that are maybe not bad advice, but very short-term advice, things that maybe work today that won't work in the future. But this idea that you're talking about here, I think is one of the most interesting and kind of like actionable as well, which is there's data available that says for the prompts you care about, you can actually see which pages are in the consideration set and which pages make it into the response. Now, everything's going to change, right? New models are coming out, new technologies, whatever, things are going to change. But like today, you can see what was in the consideration set and what makes it into the response. And I think that is maybe some of the most actionable insights that you can ground, sorry to use the word grounding, but you can ground your strategy in. If you're a real brand and a real company, right? You're not just chasing the get rich quick, and you're not chasing the bad advice, but like there's something in here which is fundamentally kind of useful and insightful. Now, again, to your point, there's still some pieces that are a black box. We don't fully know, why certain things are chosen, why others aren't. But again, to your point, it sounds like if you look at enough of this stuff, there are some patterns that emerge and insights that you can learn.
Correct. So this is us getting as close as we can to the concept of mechanistic interpretability without truly opening up the hood and looking at the model weights. So we'll never will.
Right.
But just a little bit of hint for those who are extra geeky. If you want to look at the models that OpenAI has recently open sourced, that's a glimpse into how their models are structured and how they work. Obviously, similar to how Google didn't open source Gemini, they open sourced Gemma. Gemma was built on the same training data. It uses the same language, same tokenizer. The token IDs are identical, Gemini and Gemma. If you want to look at that, it's the same technology. So I'm not saying that if you look at Gemma activations and weights and everything else, that you will see exactly how Gemini works, but I'm also saying it. I think it's as close as you'll get to understanding Gemini by observing Gemma's activation. But this is super geeky stuff. Probably a completely separate session, and we need perhaps some machine learning specialists properly to help us drive that conversation. I got pretty close to it, wrote some pages on it, but decided to bring it back to more practical, applicable methodology that my people within the agency can actually use. Bit of context. So when we have a grounding source like that, little chunk that was selected, we as users, we see what's on the left. Model sees kind of like what's on the right, but sees it with more of an attention pattern. And this is the next important piece of work that we focus on internally. So the models sees a piece of text like that, like what we see on the right. Certain elements draw more attention to it, and certain elements draw less attention to this different piece of text. It's by design how transformers work. It's an attention-based mechanism. They literally have a paper called "Attention is All You Need."
Right.
But it's not really text. They see tokens, not even tokens like this. They see token IDs. Basically, if you think of Gemini's vocabulary, each word in its vocabulary is a token, and each token is encoded with an ID. So you have what model sees as input is actually token IDs, which are then represented as vectors. So each ID, let's say 4232, is represented as a single vector. Every single vector is passed through the layers of the neural network. And this is where the attention business happens, right? So certain tokens like events has a certain attention pattern, and another token has a different attention pattern. And the positions of those tokens in a sequence actually matter and determine the attention pattern. So if you precede a token with something, and if you precede it with something else, it'll have a different attention pattern. I know this sounds a little bit abstract, but we'll get to the practical side of this and what to do with it. I promise it's actually actionable. So in SEO, we always thought, okay, understanding what Google does and why it does it, try to reverse engineer their algos, and then element of control, right? Like link buildings, content, technical SEO, whatever else we used to do. Beautiful symmetry in machine learning space that I'd like to point out, and why SEO is the perfect custodian for AI visibility. There's no need to fantasize about these new disciplines, SEO is perfectly placed to take over this. Understanding is literally the term in machine learning is mechanistic interpretability, why the models do things, and control they refer to as model steering. And so I try to align as much as I can to that. So understanding is what we've been talking about so far. We're trying to understand the models, but we're not yet to the control part. So my way of thinking about visibility tracking, and this is where I've got friends who work with SaaS businesses that do prompt tracking. I disagree with that. I think prompt tracking is busy work or AI work slop type stuff. I think you can already distill the model outputs at the root level rather than creating busy work and do natural language processing. So I'll skip quite fast over this. Basically, do the brand, entity, and location associations and probe the model to say, what does IKEA do? 10, 10, 10. So basically, if you do this seconds, one after another, it'll always give you different results because that's how models work. They have sampling and they have temperature, which allows them to sample deeply from probability space of the next token. In this case, the model can only say one thing at a time, and is limited to 10. So I'm already distilling at the API level. So I'm trying to understand, give me top 10. I don't want anything. I don't want a sentence. I don't want a loose prompt. So I'm basically providing structured output and measuring what model says over time. And our frequency of measurement is actually weekly. So we look for movements in this order of things as they appear. So we look at frequency and rank, and we're noticing the authoritative brains don't oscillate, but less authoritative brains do oscillate in the responses. So that's something that we can use. So basically, we normalize the frequency in average position, so it's all on the same scale, so 0 to 1, and we use the product of the two as the weighted score. As simple as that. And then we measure that over time to understand, are you on top of mind? So basically, how frequently you mentioned, and when you are mentioned, what is your position in the order of things? So considering this is all probabilistic and it moves around all the time, so there's no honest way of saying this is rankings. It's not. These are probabilities, and you have to treat them as such. And something like a weighted score that we use is probably a fair way to represent this without saying, oh, these are the rankings. And what I'm against is like coming up with 10 arbitrary prompts or 100 arbitrary prompts and tracking them on a daily basis. That's ridiculous as far as I'm concerned. So once you have that, you can do brand influence and brand mentions and so on, because you can treat the whole thing as a graph. So basically, we've got this tool is available. Everyone, you can just log in and measure your visibility for free. So model probing. So this is what happens with models when they do probabilities. So this is one of our clients. Ohio is A, and then what the model will say next depends on its random chance sampling. The most likely thing that we'll say is company. And the second most likely thing is German. And actually, this was a problem at the time. And I'll explain probably why. And then custom, and then brand, and manufacturer, right? So every time you say something, that influences the next token. So when you say company, that's the sentence it's going to say to describe the brand. When you say German, it'll say that thing. So every time you change a token, it says something else. So, and this works at every single token level. So now we have sports, and that's a junction. The model has a decision to make, and it's like a branching of logic, right? If it says sports, it'll say one thing. If we say team, it'll say another thing, and so on and so on. And you can see how this goes to infinity of possibilities, because at every token, you have another junction. It's almost a fractal type situation, isn't it? But it's nice because we can treat this. This is a network of concepts that we can treat and run PageRank and eigenvector centrality, things that we're familiar with. So if you take a brand, this is a tool that we use to probe the models called Tree Walker, which runs the probability walk on all this stuff. So that's that same company that ended up in a prompt. We asked the model, what does this brand do? Without grounding, no search results. And then we asked the same question with grounding. And then we asked the model to self-score. So this is the context for this slide. Before and after grounding, and then the model self-evaluates. How did I do? And then we look at the probabilities of each token from the API response, and we say, how uncertain were you about each token in this sequence? And so things that are highly uncertain are bright there, and things that are very confident are low. So this is uncertainty chart. And this already gives you a little bit of an insight as to what model is confident about your brand and what it's not. So high confidence tokens are up there, low confidence tokens are down there. What's even better, we get to see all the probabilities that model could have set, but it didn't, because you only had one shot at a sentence. But if we were to repeat the sentence, if we were to have the luxury of parallel universes, we could see everything that model ever wanted to say. And this is that space of probabilities, that all the things that the model wanted to say, catering, food, this delivery, etc., etc. So this tool that we built actually allows the model to start from that junction that it didn't, path not crossed, path not taken, can go back and take that alternative path and run that sentence. And we do it again and again and again. And we observe this is low entropy and this is high entropy. These are high uncertainty moments. So it's the tokens that constantly appear at the bottom of the confidence level, or high entropy tokens. These are the flip-flop points. Model could have said one thing or the other, or three different things with equal probabilities. This is the, like, for example, about this, the model doesn't think they're very innovative. It could have said some other things about describe this brand. And one thing to understand about this is that sometimes innovative will be high confidence, sometimes low confidence. It all depends on the syntax and the structure and the semantics of the sentence. So that's something to keep in mind. So we have an interpretive layer of that shows you high confidence, low confidence tokens. It shows you where it varies. It's like sometimes it shows you 99% accurate confidence, sometimes drops significantly if it proceeds with certain patterns. So this is like our first level of understanding what ruins the confidence of the model, what things have. So that leads to content optimization opportunities. And so the next level is basically entering the brand in our system and saying, list all the things that you think this brand does. And we take that list and we come up with a list of competitors by asking it a separate question. So for each competitor and for the brand, we ask, would you recommend this brand if somebody was searching for that? Yes, no. Don't tell me the story. I don't want your output. Model's output is restricted to a single token. What's interesting about this, we ask it yes or no, and we only capture the probabilities for yes. If the model says yes, no, we just ignore that, and we look into its head to see what it was going to say. The probability was, oh no, what the probability was for it to say yes. So in this case, the probability of it saying yes was 42%. So this is an instant probability of whether this brand will be recommended. If, let's say this is in grounding situation, this is one of the search results presented to the model. What we're measuring here is what I call primary bias. The model's training data opinion about your brand and its association with a certain entity. This is the entity Caterers Brisbane, and the model's association with this domain for that entity is that low, but for this is that high. So this doesn't mean that that's the exact percent that you'll be selected. That's not your selection rate. This is the bias that this model has against or for your brand towards certain concepts. Why is this useful? When you're optimizing your on-page content and off-page citations, you don't focus on this part. You focus on this part, if this part is of commercial interest to you. All right, this is immediately practical. Look at that. Catering near me, that so low. So so you will notice how we're probing the domain towards entities, but we're also probing entities towards all domains. So you can immediately print a competitive matrix to see which competitor is strong or weak at which entity that you matter for. And then there's an element of confidence mining in sentiment. Did the model pick up negative things or positive things about your brand in the training data when it was being trained from the internet corpus? So association boost, we also have the tool for citation mining, so you can actually see what the citation source is for whatever prompt. So obviously this goes into the automation pipeline that I just presented, so we'll skip by that.
Wait, and just to pause there for a second, if this is a good spot, like there's a ton of technical work here, and I think there's a ton of stuff that is really great and amazing. If I can maybe put words in your mouth a little bit and just kind of zoom out.
All right,
I think there's a really important distinction here, right? Which I completely agree with, by the way. I'm 100% aligned with you, which is if you just grab a bunch of random prompts and you track them every day, just like you used to do keyword ranking in the old school SEO days, you're missing what is deeply different and new about this new world, which is that we're actually able to move much more closely back to what real brand marketing cares about, which is brand awareness, preference, and saliency, right? Which are the things that brand marketers have known about and tried to influence for a very long time.
Ages, yeah.
And that you can actually get a much better understanding of what the model thinks about you, rather than just what is the end thing it happens to spit out for this one random prompt that you happen to track every day, right?
Yeah,
and that for me is like a critical distinction, which I think is very interesting about the future world, which is, rank tracking in old school SEO days was always an approximation of what Google thinks about you, right? It was always like, but it was the best we had, right? The best way to understand what Google thought about you was to Google something, right? But actually now with these LLMs, you actually have the ability to interrogate more closely and probe in different ways for what do you think about my brand? What do you think about this web page? What do you think about this website? As it relates to different kinds of intent, different kinds of user behavior, and so on. I think that's exciting because despite the fact that a lot of what you just showed is kind of deep tech, like it's like very like nerdy, it's like technical, it's detailed, it's cutting edge. At the same time, we are moving to a world, I think, which is much more like human-centered. Of this much more closely mirrors how humans feel about brands and how humans feel about web pages, which is that's kind of like a big innovation, I think. So I don't know if I misrepresented anything you said there, but I'm on the same page as you that like this is fundamentally a better way to understand what's going on than just kind of raw, naive prompt tracking.
This is why I'm having you on this screen recording today. That's perfectly well put. In essence, what we're doing now, we're doing model psychology. Right?
Yes.
We're trying to understand the model's biases and associations in respect to products, brands, services, and so on, to understand how its decisions will skew in which direction when it's in a situation where it needs to make decisions, when it's doing the grounding, when it's doing the synthesis of its answers. So that's perfectly well put, and probably cuts down all the complexity that happens in the background to a more comprehensible level. So all this citation mining business leads to useful data that is immediately actionable for outreach purposes, for content optimization purposes. We've got some beautiful scoring there. We've got some selection decisions, grounding URLs, unselected URLs, so if we go back to that moment, we, in addition to the grounding and citations, now have sources. So the missing link here, and I've got this happening at the moment, we also need to scrape the targets and understand what they look like, right? Not just your own website, but all the competitors. So super hack for everyone who's not aware of this. If you want to get the exact information about what Google has on any URL on the planet, you can just use Gemini's URL grounding API. Works in the same way or a similar way that the search results API works, but you can ground with URL. You can literally ask Gemini to give you intel on the page. It's very resistant towards giving you the raw grounding snippets. I have a hack to extract that out of it, and it's an active area of research. I'm not sharing that because it's changing. It's actually changed today, the way they do it, and they have a blocking mechanism in place. I've made a mistake writing about this. I don't know if it's because of me, probably too egocentric to think that it's because of me, but they've changed something and they have measures in place to prevent models spilling its raw grounding snippets. The reason I do that is because it's not like this, it's like this. Bits and pieces of your content are supplied as a grounding context, not the full page. So in the visibility optimization cycle, that leads us to So you've got your organic queries and their fan outs. You've got the synthetic queries to close the gap. You're trying to understand the negative bias. You're trying to predict the value of different keywords. You're working on strategy to optimize on page. You're mining citations and hope to build citations to get more visibility. You're doing outreach for the purpose of entity associations. And then you are working on selection rate alongside your click-through rate. So click-through rate is for humans. Selection rate is for models and agents. Obviously, they don't click, so they select out of the pool of things. So I introduced. So this is what Dan is busy right now. Okay. So selection rate optimization, how I think about it. So we do the citation mining, which we hope to improve the on-page optimization for better citation stuff. And we touched on that when you talked about the compression tool, semantic compression tool. But we also want to do citation building. So here's my workflow. I harvest the organic queries from Search Console. I generate the fan-out queries. From fan-out queries, I generate the synthetic prompts. We've seen that part before. Then what I do is I extract the organic snippets, the actual snippets that appear to Gemini in the grounding situation. And then using that logic, I train a model to generate synthetic snippets based on the synthetic prompts, right? That's my setup now. So I have the synthetic prompts, I have synthetic snippets. So effectively what this gives me is the ability to dedicate a selection model and present this model to something very similar to it. Here's the 100 grounding results, and one of them is my client. Pick which ones you want and make a result for this prompt. So if somebody's searching for dinner ideas, there are 100 results in the grounding sources, and one of them is my client. How often will the model, this selection model, choose my client out of the 100 results? And how often, if I repeat that, how often, what is the selection rate of the selection model when presented with these synthetic grounding snippets plus my client? And then I do the judge model. The judge model will evaluate that selection, make a note, and inform the rewriter model. Rewriter model will actually don't care what it does. It'll just randomly rewrite my client's snippet, put it back in the loop. I think if you're smart, a lot of light bulbs are lighting up right now. This is basically CTR optimization on steroids.
Right.
Because you can rapidly cycle through this process. Once you have this pipeline in place, you can go insane speed of iteration. So the idea is that you become from whatever 5% selection rate, if you're lucky, towards 10%, towards God knows what. Like, so the idea, the end goal for me is to make my clients' snippets, when presented to the model, absolutely irresistible. It must take it. So I'm trying to, that's the active area of research that I'm busy with, trying to understand how do I get my clients to be 100% selectable. That's the goal. Obviously, 20% will do. Maybe that's even overly optimistic, but so, and one thing to keep in mind is that this is the presentation layer and influencing the model decisions. To get there, you need SEO. So I treat all this as SEO, and that's why I made a point. AI is part of what we do, right? That's why I made this point with this. And so all these tools, and that's just to help you get to that presentation layer. If you haven't done the bread and butter SEO optimization and all the other bits and pieces, you're not even in the mix.
Right. You're not even in the
selection.
Right.
Yeah.
Right.
Yeah. So AI, presentation layer, SEO, the backbone, and the memory layer of all these AI models. And what we're playing around with here is understanding the model's internal biases towards brands and products and services, and understanding how to gear those towards optimization work, so we can influence the model's selection. So this is, of course, one part of the whole pipeline. The whole pipeline is a lot bigger. So we just described, basically selection rate optimization. Of course, there's the citation building to get into the grounding sources, and also mention buildings to be one of the brands mentioned in other people's citations, doing on-page optimization to be more attractive, and making sure, like you mentioned, that your snippets are well optimized. So when the Google's selection logic that builds the snippets that go into the grounding citation, when it's built together, that it doesn't take your snippet out of context and it doesn't have the legs to stand on. Each semantic chunk on your content piece must hold its own ground and be a semantically cohesive unit. So